Let's talk about models, that is language models, the engines of AI applications like copilots, but also for your own custom AI apps. Let's dive in. Now, before we begin, it's important to know that AI has existed long before ChatGPT, long before large language models. And old AI technologies, like you see in the blue here, focused on how to classify things. And what you see, those little circles, those are neural networks. And they could analyze a picture like that picture of my dog, and after having been trained with, say, 10,000 labeled pictures of dogs and cats, it could usually pretty accurately figure out that this was, in fact, a dog. Or on the right-hand side, this is, in fact, a happy customer that tweeted about our restaurant. But then generative AI came along. And with generative AI, we generate new content, wholly new content, using these pre-trained models. So we can generate a picture from text, show me 3 dogs dancing on the moon, which was the subject of a blog post I wrote some time ago on the Directions website, or where does the name Dolly come from? It's really pretty clear now that models for generative AI that can generate new content like this change the world. And we'll remember November 30th, 2022 as the day that happened. Really was the beginning of an era. The academic paper on the right actually was the basis for all this in a sense. It recognized that to understand language, you really need to understand, that is, pay attention to words in their context. And that's a very simple explanation of a very complex concept. In any event, Microsoft soon after licensed exclusively OpenAI's models and introduced them in Copilot and made them available for developers in Azure's OpenAI service. Key takeaway from all this, models are the core component that run generative AI applications, including chatbots and copilots and summarizers and agents. Let's just digress for a second and talk about, why does AI require these enormous investments we keep hearing about in data centers and GPUs? And the answer is that training a large language model is incredibly compute intensive. And there's a ton of math. It's pretty straightforward math, matrix multiplication and exponentiation, but it's done at extreme scale and running extreme parallelism. Now, the interesting thing about this is that it's pretty much what the same types of calculations that a graphics processing unit does when you're playing a video game and it's rotating an image or killing an alien. And NVIDIA discovered this, that they were perfectly positioned to do not only just graphics, but also AI. And that's why I say NVIDIA was the luckiest company on earth, and that has generated a pretty immense market cap. Now, training LLMs is pretty compute intensive. Inferencing, which is solving problems on a trained model, requires much less compute. Why is all this so hard? Well, here's a simple way of imagining this, and I promise you this is the only math in this deck. If you remember from high school, the slope of a line, y equals mx plus b, well, there are 2 constants in that equation, m and b. GPT-3 is solving equations with 175 billion constants. These are called weights, by the way, or parameters. DeepSeek R1 is the big one, is the recently announced one, is 671 billion parameters or weights. That's why we need tens of thousands of servers. That's why we need the cloud to do training. Amazingly, in the short time since November 2022, these models have become commoditized. We have these general purpose large language models, they're foundational models such as GPT-4o and Llama 3b, open source from Meta, Google's Gemini. We also have targeted low footprint models, which we call SLMs, or small language models, because they're trained on much fewer parameters than the large ones. These can be deployed for special workloads, for on-premises cases at the edge. Microsoft's own 5.3 and 5.4 are examples. And we're also starting to see the emergence of next generation models, such as OpenAI's O1 and their forthcoming O3, which are capable of planning and reasoning, which we've seen actually in DeepSeek that just came out very recently. But to give you an idea of why I say these are commoditized, there's a public model repository called Hugging Face, and it sports currently over 1 million freely usable, freely downloadable models. Azure itself has well over 1,800 of them that developers can choose from. Here's a quick screenshot. We'll take a little bit closer look at this later, but these are the some of the models that Microsoft makes available for developers to use. You can also do this on your desktop now. There's a vibrant social media enthusiast community for this application called Olama, which allows you to download a slew of LLMs, assuming you have room on your machine to run them. And you can, from the command line, in this case I'm running Phi3 and I'm asking why is the sky orange at sunset, and there's all sorts of YouTube videos that you can watch to learn all the tips and tricks of running LLMs locally on your desktop, and it's kind of fun. Okay, let's talk about agents. Agents are, of course, models that do things for you. They take actions on your behalf. They're more than a glorified search. They actually take actions on humans' behalf, potentially reducing your work, potentially reducing the workforce as well. And obviously, there's a lot of hype about this. Let's take a look at it. The canonical example is, of course, customer service. User calls customer support with a question, and instead of an IVR answering it with those terrible voice trees, we get a friendly LLM that can take down the customer's information, that can record the customer's problem in detail and get all the context and nuance and so forth, can look up information in knowledge repositories throughout the enterprise, can potentially route to another agent if either human or automated if it can't answer, maybe even invokes, let's say reverse logistics, return the product process, and so on and so on. If this sounds like a lot like an improved IVR, well, it definitely is. If it sounds like business process management plus, it kind of is, because if we think about what these scenarios really are, there's an event, in this case the customer calling, there's some sort of processing, and then some sort of resolution to that event. In the old days, that processing was a human, for example, or an IVR, or it was some code, or it was a rules engine, and now we're replacing all that with an LLM. And if this sounds a lot like what an application, like a customer service application, or CRM application, well, remember that slide that we showed up at the beginning. This is, in fact, a harbinger, perhaps, of the new application model, the new AI native application model. And moreover, the latest generation models can plan and reason, as we said. So maybe in some point in the future, they can even create their own ad hoc business processes on the fly, which is kind of an interesting, exciting, maybe even scary possibility. Now, of course, any discussion of models wouldn't be complete without a discussion of safety and bias. And what we've learned is that these LLMs are really only as good as the data they're trained on. And if the underlying data is biased, even if unintentionally, well, that's what the results are going to be as well. So if you look on the right-hand side, the Washington Post did a fascinating study where it just simply asked various LLMs to draw a pretty woman. And in this particular case, about 9 out of 10 were light-skinned. And that's kind of amusing, but with AI robots that scan resumes or filter college applications and so on, the thing is, LLMs are often, and the training for LLMs are often based on what? Past successful candidates, and that can introduce bias. So Microsoft, to their credit, has pioneered principles, and they actually have quite a number of tools behind their Responsible AI initiative. You can click on the link and you can go to their Responsible AI page. They have a whole bunch of tools to help measure how well grounded the AIs are, the models are, how if they generate harmful content and so forth. And we know that Microsoft and OpenAI use these. To what extent, like other open source LLMs do, we can't really always say for sure. Lastly, I hear this question from time to time: is Microsoft competing with OpenAI? And I don't think so. And first of all, we'll say that Microsoft has been investing in AI for a very long time. Microsoft, it was actually one of the very first projects or initiatives that Microsoft Research became involved with back in the early 90s. We'll say that, we can say that Microsoft has invested a lot in OpenAI. The specifics they haven't released, and they are closely held. It's believed to be about $13 billion or so over multiple rounds, multiple tranches. What the form of that investment has not been disclosed, whether it's cash, Azure credits, or what have you. Microsoft hasn't had any hesitation in making their own models. They've introduced the 5.3 and 5.4 models, a couple others that have not gotten as much notoriety. But the point is here that we believe, and I think Microsoft believes as well, that there's decreasing differentiated IP in the models themselves. The models are only important as components of larger applications. So Microsoft has a great partner in OpenAI. That lets them focus more and more on the uses and applications and the workloads that AI applications can address. All that having been said, it is possible that DeepSeek, which does a lot of the same things, at least allegedly, that OpenAI can do, if it all turns out to be true, DeepSeek may change Microsoft's long-term view of the value of OpenAI. We're not sure. Summary points about models. This is an arbitrary segmentation. One way to look at it, they're premium foundation models like GPT-4 and 4.0 and 0.1 and forthcoming 0.3 that have new features and are evolving in new ways beyond simple content retrieval. There are a set of commodity models that you can use in Azure, like Llama 3 and DeepSeek for that matter. And some of those can be locally downloaded using Llama on PCs or Macs, and you can use them to build custom desktop applications that are AI enabled. We talked about how models can be customized before when we were talking about Copilot. We can customize them using either RAG or another technique called fine-tuning, and we'll talk more about that in a minute when we talk about AI Foundry. In both cases, Azure and OpenAI both guarantee that your private enterprise data is not exposed to the public models. We don't think that the commoditization of models is likely a threat to Microsoft's strategy because Microsoft is focused in a different area. Microsoft wants to be the AI solutions provider and the tool set for AI applications. And finally, models are evolving into agents which can run autonomously and execute actions. Will they replace code over time, as we posited early on in this presentation? Will they run the business logic? Will they actually become applications? Interesting thought. Let's keep going.